Friends, in this video we're going to learn about how continuous wave radar is worked using the block diagram operation. Before knowing how continuous wave radar works, we need to know about Doppler effect, because continuous wave radar employs Doppler effect. So whenever we consider an observer and a sound source, and the sound source is at a far distant, we hear only less sound. Whenever the sound source is coming towards the observer, we hear more sound. Okay, now consider the other case. Whenever the sound source starts from the observer, we have more sound, and whenever it goes farther, then we have less sound. In both of these two cases, we have frequency shifting taking place. That means there is a shift in the original frequency by some other frequency. When we subtract these two frequencies, we get a frequency called Doppler frequency, which is given by 2Vr by lambda, which is mentioned over there. Okay. Now coming back to continuous wave radar or Doppler radar. The important features of this radar are: it uses Doppler effect, and it is used to determine velocity of the object, not the range, and its duty cycle is 100%. As we all know that duty cycle is time of operation by total time. Here in this case, as it is mentioned, a continuous wave radar, the transmitter going to transmit the pulses continuously, so T on will be there and T off will be absent, whereas total time is T on plus T off, so T on by T on equal to 1, we get 100% duty cycle. As the waves are continuously transmitted and there is no time for the receiver to receive the signals or receive the pulses, the range, there is no time difference between the received and transmitted signal, so there is no time difference and we cannot get the range, so minimum detectable range is 0. And the one more difference as compared with pulsed radar is it requires two antennas. Continuous wave radar requires two antennas, one for receiving and one for transmitting. Now we go on to operation of the continuous wave radar. So as you can see in the block diagram, there is a transmitter section which is RF continuous wave oscillator, radio frequency oscillators. As we know, continuous wave radar operates at radio frequencies. Okay, and an antenna connected out. So we use an antenna to radiate these pulses, and whenever we encounter a target, we receive an echo, and you can see the other antenna pointing in, and this discriminator amp and mixer is receiver section. Okay, whenever we encounter a target, we are going to receive the echo signal, and this antenna acts as a receiving antenna, and this sends the received signal to the mixer, wherein this mixer, it compares the values of transmitted frequency and the receiving frequency, and it subtracts these two frequencies. It makes the difference between these two frequencies and gives us a Doppler shift. Okay, now here we use an amplifier. The amplifier is used to amplify this difference, like differential amplifier. As we all know, V1 is the input and V2 is the V1 and V2 are the inputs. Then differential amplifier will give us the output as V1 minus V2 into some gain. Here this op amp does the same thing. It amplifies the difference between these two frequencies, and the output of this amplifier is given to the discriminator. Here this discriminator acts as a frequency to voltage converter, and this discriminator converts the input frequency from the amplifier, and it converts into the voltage which is indicated in the indicator. So the main thing here we need to understand is continuous wave radar doesn't require runtime measurement, as we are not calculating the distance, but we are only interested in calculating the velocity of the objects or targets. We get the velocity equation by Fd equal to 2 Vr by lambda by Vr is the radial velocity of the object. Okay, whenever if the object is not in the radial direction or radial distance from the radar, then the formula changes to 2v cos alpha by lambda, where alpha is the angle between the radar to the target. So one more thing about the operation or block diagram is when we come to the components of the continuous wave radar, we use a power supply. Of course, there will be need of power supply for transmitter, receiver, and also discriminator and indicator. That power supply generally we use a magnetron or any vacuum tube devices, as we already studied in microwave engineering in the previous semester. Okay, those antennas which we are using for in and out are mostly of parabolic reflectors or horn antenna with high directionality. That's all for the explanation of continuous wave radar. Thank you.